Hello, Math 2 Extended. This is Mrs. Bricky, and this video is Unit 3, Lesson 3, Solving Equations by Factoring. So, there is something that is called the zero product property. It's a really logical thing when you think about it, but if you have an equation that is A times B equals 0, there are two things that make that equation true. There are two solutions. The first solution is that the A could be a 0 because 0 times B is 0. The other solution is that B could be 0 because A times 0 is also 0. So that is called the zero product property. If two things multiply together to give you 0, there are two solutions. So maybe the A is fancy. Maybe the A is an R minus 2. What value could R have to make that statement true? And hopefully you're thinking to yourself, well, if the R is equal to 2, then the R minus 2 is 0, which would make the product equal to 0. So R equals 2 makes that a true statement. And what value could S take on? What if the B was just a fancy, or what if the B was a little fancy and was an S plus 1? Well, that S plus 1 could be 0, and in that case, we would have the solution that S is equal to negative 1. So an equation like this has two solutions. What are the two values that make this equation true? Well, the zero product property tells us that either x minus 4 is equal to 0, in which case we have the solution by adding 4 to both sides of our equation. We have the solution that x is equal to 4. And our other possible answer comes from x plus 7 equal to 0, in which case we would subtract 7 to get our second solution. So there are two solutions to this equation, x equals 4 and x equals negative 7. I want to verify via substitution that this really works. So if we sub in 4, we get 0 times 28, and that is, in fact, 0, so it worked. If we sub in a negative 7, we get negative 11 times 0, which is 0, so it works. All right, so let's compare these two equations. They don't have the same solutions. I want to know, what are the two solutions to each equation? So we are going to take our factors and set them equal to 0 to get our two solutions. On this one, we come up with the first solution of 2. And on this one, we come up with a solution of 6. So our two solutions are 2 and 6. And you absolutely, when you're writing these two solutions, can separate them with a comma. Just make sure you don't put them in parentheses with a comma, because in math that means something completely different. A comma is just a list of things, so this is a list of answers. Parentheses mean that it's a point or an interval. All right, so let's look at this next one. It looks almost the same. It has a minus 2, it has a minus 6, but the difference here is that I have a 5 with my x and a 7 with my 6. So let's think about how that affects our solution. I set my first factor equal to 0. I add 2, just like I did before, but this time I'm not done because there's a 5 with my x, so I need to divide by that coefficient. So I get a fraction answer. X is equal to 2/5. For my second answer, I need to add the 6 just as I did before, but the x has a coefficient, so I also need to divide. So I get the solution 6/7. So you can have fraction answers come up, and that's fine. You could always verify your answer by subbing in, and 7 times 2/5 minus 6. And if we, you could calculate that maybe in your calculator, but this first one is going to be 0. So it doesn't even matter what the second one is, because 0 times anything is 0. So you can always check your answers when you're solving equations. There's our two solutions, fractions. Some factorizations include a monomial factor. So I'm going to talk about how these monomial factors affect our equation's solution. So over here I have 5 times something equals 0. Well, if you have 5 times something equals 0, the 5 is just a 5. I mean, we could even, if we wanted to, divide both sides of the equation by 5 to cancel it out. You don't need to formally do that, though, if you can just realize, oh, that 5 doesn't matter. The two factors here, where you see the x's, those are what contribute our answers to our equation. So we have these two equations, 2x plus 5 equals 0 and x plus 1 equals 0. Each of those is going to contribute one of our answers. So the first factor gives us the answer. We subtract the 5, and then we divide by 2, and we get x is equal to negative 5 halves. Our second factor, x minus 1, gives us the solution x is equal to negative 1. So our two answers are negative 5 halves and negative 1. The 5 did not affect the answers to the equation, the 5 coefficient right here. This one, I've got a monomial factor of 3x and a binomial factor of x plus 8. The 3, just like the 5 before, the 3 could be divided away. It's not necessary to show that division, but if you wanted to, you could divide it away. It's not affecting the solutions to the equation at all. The x's are where our answers come from. So this has two factors, or two x's. I have one here and one with this 8. Each of those contributes an answer, and we set each of those equal to 0. And you can keep the 3 with the x if you want and think about dividing it here. But the 3 is not going to affect the answer. One of the answers is 0. 3 times 0 plus or times anything gives me 0. So x could be 0 is one of my solutions. And the other one is negative 8. So when you're deciding what your answers are and you have a monomial at the front, really think about, does it have an x? If it has an x, it's contributing a solution. If it doesn't have an x, it's not affecting the solution to the equation at all. Okay, this one has 3 x's present. All of our other equations have only had 2 x's present, but now we have 3 x's present. So thinking about our zero product property, if A times B equals 0, we know that A is 0 or B is 0. We have two answers. If we have 3 things being multiplied together, the zero product property works as well. It's just that we have 3 solutions. A equals 0, B equals 0, C equals 0. So on this one, we're going to have 3 answers because we have 3 x's present. The first factor is a 2x. And again, it's because of the x that this is contributing an answer. The second solution comes from x minus 7 being equal to 0, and the third solution happens when x plus 5 is equal to 0. So the first one to solve, I divide that 2 away. X is equal to 0. The second one, I would add 7 to both sides of my equation. So we have x is equal to 7. And the third one, I would subtract 5 from both sides. So I get x is equal to negative 5. So this equation, because it has 3 x's present, it has 3 solutions. Okay, the past few equations were already in factored form, but if we have a quadratic that is in standard form, we can factor it to find the solutions to the equation. So this first one is a little bit tricky to factor because it's got a coefficient of 2, but that coefficient is not a common factor, so we can't factor it out. That means we have a 2 with one of our x's to give us that lead term of 2x squared. The 21 over at the end, probably most likely is going to be a 3 and a 7. So let's see if we can find the right combo here. And remember, if needed, it's not a bad idea to sort of fill in both both of what you think it might be and kind of check what those middles are. This one's a 3 and a 14, so that doesn't help me get a 13, but this one's a 7 and a 6, and that does help me get a 13. So it's not bad to write some stuff out, and you don't need to erase it. You can just cross it off on your paper or on your test. Just be clear that you're like saying, oh, it's not this one. To get a positive 13, I do need those both to be positive. So we factored it this time, but now that we have it factored, we're ready to get our two solutions. One solution comes from each of our factors, and we can solve these two little equations, first subtracting the 7, then dividing by 2 to get our first answer, -7/2. And for our second answer, we just need to subtract 3 from both sides to get a solution of -3. If you are thinking to yourself, when I see this, can I just write down the two answers without formally writing out all of this stuff? And I would say to you, absolutely yes. You do not need to formally write this out if you are able to go from here straight down to here in your head without making errors. Now, if you're making errors, take the time to write out the steps. Maybe if there's a coefficient, you want to write out the steps. I don't know. Be mindful of how your brain is working and make it work for you. So if you want to skip those formal writing out of the solving, by all means do it. I never write it out when I'm doing my own work. But definitely if you're making errors, be aware of that and take the time to write it out if you're making errors. Okay, I've got 3x squared minus 48 is equal to 0. I've got a coefficient of 3, maybe 48. You're not sure if 3 goes into it or not. Go ahead and divide it if you're not sure and see. But it turns out 3 is a common factor here. So we're going to factor out the 3. That leaves us an x squared minus 16. 48 divided by 3 is 16. So we can factor that. That's got a 0 middle term. So that's an x plus 4 and an x minus 4. So our two solutions are -4 and +4. You absolutely can write that with a plus or minus symbol if you want. That's just shorthand. So whichever way you like, list it separately or use a shorthand symbol. Okay, a few important things. If you didn't connect the dots yet, I want to formally say that if your equation is degree 2, it is going to have 2 solutions. And if your equation is degree 3, it is going to have 3 solutions. And we have seen that coming up today. If we have a square as our power, we know that there are going to be 2 answers to that equation. If we have a third power, when we factor it out, we're going to have 3 x's present in our factorization. That is going to have 3 solutions or 3 answers. And that is actually called the fundamental theorem of algebra. But the degree of the equation tells you how many answers you're looking for. The equation must be equal to 0. We need this equal 0 right here in order for factoring to be a helpful strategy. And that's because we're using the 0 product property. We're not using the 10 product property or the 8 product property. 0 is the number that has this cool property that helps us. So make sure your equation is equal to 0 before you factor it. So here's an equation. I don't want to start by trying to factor over here. That would be a bad strategy because it is not equal to 0 currently. I need to work that equation a little bit first and get it equal to 0, and then I can factor it. So I'm going to subtract the 25x, and I'm going to subtract the 10, so that on this side of the equation, I have 0. So I have 6x squared minus 100x minus 34. This looks tricky to factor. Always, especially if it looks tricky, look for a common factor. We don't have a very large common factor here, but we do have a bunch of even numbers, so we can at least factor out a 2. That makes the middle term coefficient a 50, and that makes our constant 17. Well, the nice thing about 17 is it's a prime number. So we know that it's got to be a 17 and a 1. There's no other combo for 17. So we are going to put a 3 with one of our x's so that we, whoops, sorry, that should be an x, not a 3. So that we have that 3x squared. The 17, if I put the 17 here and the 1 here, my middle term is going to be like a 20 or something, or a 14, right? Because that's a 17x and a 3x. That's not going to work. So let's try putting the 17 so that it multiplies by the 3. In that case, I'm just going to check out these middle terms. 17 times 3 is 51, and I'm trying to get a negative 50. So if I put a negative with the 7 and a positive with the 1, that's going to give me that right combo. And that stuff I wrote down, you can absolutely write that on your paper, or if you want, just do that thinking in your head, whatever is best for you. So I have 2 x's present. It was a degree 2 equation. I know I have 2 answers. My answers are, if you can go straight to it, negative 1/3 and 17. If you can't, write it out and solve it, setting each of those equal to 0 separately and subtracting and dividing to get your answers. Okay, so write it out if you need to. Skip straight to the answers if you can from there. Okay, let's try these two. Oftentimes people do a great job of getting that 0 if they have terms that they can combine with. But then I give them something like this, like these two, and it kind of falls apart. So this one, I guess we do have something to combine with here. That's not too bad. The factoring sometimes gives people a headache here because we forget about monomial factors sometimes. The only thing these two terms have in common is an x. If we factor the x out, we have x minus 8. It's a degree 2 equation, so we have 2 solutions. We have x equals 0, and we have x minus 8 equals 0. So our 2 answers are 0 and positive 8. And that positive 8 comes from adding the 8 right there. All right, this one in particular, people have a hard time getting equal to 0 because they don't have anything to combine with. We are subtracting from this side of the equation, from both sides, I guess. None of these terms combine, so that's our trinomial. 2x squared minus 8x minus 10 equals 0. So don't let it trip you up if you have nothing to combine with. That just means they're their own terms. We can factor out a 2 here. That's x squared minus 4x minus 5. And we can factor as x minus 5 and x plus 1. So our 2 solutions are 5 and negative 1. Okay, this is the very last thing. We recently used square roots to solve equations. We could technically do that on the second problem below. The factoring will also work. But we can't use a root to solve the first equation. And I want you to think about why. And I also I'm going to write up an equation. Here's an equation like we would use a square root on in Unit 2. So hopefully you recognize that the reason that we can't use a root is that this middle term exists. that 9x is causing a problem. If we could, maybe if we were trying, we would try something like this. Don't write this down. This is not good, okay? Maybe you try moving the 36 and you take the square root, but a square root can't break up over that addition. So this doesn't become an x, and even if it did, what would this become? Like, it just didn't work. Maybe you're like, well, okay, maybe I'll take the 36 and the 9x over. So you have x squared equals 36 minus 9x. Well, again, if we rooted both sides, this side now would be okay. It would just be an x. But this side, I mean, I can't turn this into a 6 because it's with the 9x. And the 9x can't really be anything. It, could be a 3 root x, except I can't separate it anyway. So it just didn't help. A square root just didn't work. And that's why on some equations we need to use factoring instead. If you have a perfect square and that's your only x, square rooting works great. If you have a square and a regular x, it doesn't. So this one we would have to solve by factoring. 36, I think our combo here has got to be 3 times 12. List out all of them if you need to. X plus 12 and x minus 3. So our two solutions are negative 12 and positive 3. I want to show you both factoring on this one and square rooting, because this one we could technically square root if we wanted to. So if I was factoring this, I would go straight to my binomials. I would recognize that I have a 0 middle term. Oh, my 6s are not good today. And then I would get my two solutions. Well, I could have, oh, my 6s just do not work. My pen must be getting low on batteries. So I get those two solutions, positive 6 and negative 6. If I solved the equation with square rooting, my strategy would be a little bit different, but I would get the same answers. So I would add the 36 to get my square isolated, and then I would square root both sides, getting my plus or minus symbol, and I get the same answer, positive and negative 6. So both strategies work in this case because of that 0 middle term. But if you have something like a 9x or some other linear term with an x in it present, then factoring is going to be your go-to method. All right, thanks for watching the video. Sorry I couldn't, if you're with the sub, sorry I couldn't be there with you today. If you're having questions or troubles, I'll be back next week and you can come in and ask me questions. Thanks a lot.